Good afternoon, dear students. Am I audible? And is the screen visible? Okay, fine. Okay, so yesterday we have started with a new topic, that is alcohol, phenols, and ethers. Okay, so we have solved some 20 questions yesterday. Okay, so the same we are going to continue today. Okay, so we are going to continue with the same. Okay, so remaining questions we'll be discussing in today's class. So whoever has not taken the test yesterday, okay, so you can take the test today also. Okay, so the link will be sent in your group, so Google Forms. So there you can take the test. Okay, so I hope you have gone through the synopsis, right, which was sent about alcohols, phenols, and ethers. Okay, so the important concept have already been sent to you. So based on that, we are going to solve some questions. So let us start. Yes. Okay. So this is a question. Okay. Consider the following reaction. Okay. Ethanol reacting with PBr3. Okay. Then you get the product X. This X, whatever you get, further you are going to react it with alcoholic KOH to give you Y. This Y, you are going to treat it with what? H2SO4. Okay, that is sulfuric acid at room temperature, and you're going to treat it, you're going to do hydrolysis, okay, by heating it, and you get the product Z. So they have asked you which is the product Z. So which is the product Z? A, so B, C, D. So these are the options. Okay. One you have a ether. Second is one is a SO3H compound. Okay. You have a sulfonic compound. Then you have a alcohol and you have a alkene. Okay. Varun Raj has answered it as C. Okay. What about others? Ethanol itself. Okay. You have said that ethanol itself is the product obtained at Z. Okay. Others? Pavitra Mehek has also answered it as C. Vedvati has also answered it as C. Okay. So, any more answers? Any more answers? Yes? Okay, fine. So, let us see. Okay. Let us see then. So, the question, just a second. Okay. So, ethanol, that is CH3, CH2OH. Okay, ethanol is the starting reactant. We treat it with PBr3. Okay, we treat it with phosphorus tribromide. Okay. Now, here, so bromine is a attacking group. Okay. So that can be easily replaced. Your OH group can be easily replaced by this Br. So what will get? I'll get a ethyl bromide. I'll get what? I'll get a ethyl bromide. So our product X is what? It is ethyl bromide. Okay, ethyl bromide. Now this ethyl bromide, I am going to treat it with alcoholic KOH. Alcoholic KOH means what? I am going to do a what? Alcoholic KOH is used as. Yes, it is used as what? This was, we use it in haloalkanes and haloarenes. Okay, Tasmi has also answered it as C. So, yes, can anyone tell me what is alcoholic KOH used as? Alcoholic KOH means your KOH, okay, potassium hydroxide is prepared in alcohol. Okay, so it is called as alcoholic KOH. So why, what is the role of this alcoholic KOH, students? It is used as what? It is used as a,
Elimination reaction.
okay, elimination reaction. Okay, fine. Any other answers? Any other answer? Elimination reaction. Okay, elimination of what? Not that proper answer.
Ma'am, double
Elimination.
bond. Double bond, ma'am.
Uh, no, you are forming a double bond. That is also correct. Okay. But what
Yes,
you are
ma'am.
eliminating,
Mm,
it is a, okay, let us see. Let us see. Okay, fine. Others have no answers. Others have no answers. What is alcoholic KOH? So this is a repeatedly asked questions in your theory. Okay. In your second year. Okay. During your second year for board exam. So this is a asked question for 1 mark. What is role of alcoholic KOH? You did not study. What is the role of alcoholic KOH? It is used as a dehydrohalogenating agent. Dehydrohalogenating agent. Okay. So this is the role of your alcoholic KOH. So let us see how this reaction proceeds. Okay. So remember this. Don't forget for your CET point of view, dehydro means what? Dehydro and halogen means what? There is a elimination of one hydrogen and one halide group. Okay. Let us take as X. We'll take it as X. So one hydrogen. So elimination of one hydrogen and one halide group, right? So it is called as dehydrohalogenating agent. Okay, alcoholic KOH. But how, what is happening here? See here, CH3, CH, Br. Okay, so let me write this also properly. So this will be CH, H, right? So this is a alpha beta carbon, right? So this is a alpha and this is a beta, or it is also called as alpha beta elimination. Okay, it is also called as alpha beta elimination. You can remember as dehydrohalogenation. Okay, now here what is happening? This hydrogen and this halogen, okay, is removed. And what you will get the product? You will get it as CH2 double bond CH2. That is a ethene. What is obtained? Ethene is obtained. Okay. So yes, Varun has told that double bond is created. Yes, that is double bond is created. Okay. That you get a ethene. But the role of alcoholic KOH is it eliminates your hydrogen and one halogen. Okay. So it is used as a dehydrohalogenating agent. And this reaction is called as dehydrohalogenation. Okay, fine. So this is our Y. This is our Y. Now further, I have treated this with H2SO4. Okay, sulfuric acid at room temperature, and it is undergoing hydrolysis, that is water, and you have to heat it. Okay, you have to heat this. So what you will get now? So here, what is happening? Now again, at this active double bond center, okay, you are from sulfuric acid, okay, sulfuric acid H2SO4, it will create a electrophile, that is HSO4 minus. So this HSO4 minus will what? It will attack the double bond. Okay, and what will get the product? So I'll write it here. So you will get it as CH3, CH2, HSO4. Okay, HSO4. Now this, okay, so I have done the first reaction. Now I have to treat it with water. So let me do it here separately. First I have done, okay, I have treated the first reaction. That is, I have treated it with what? I have treated it with HSO4. Now I'll treat it with water. Okay, I'll do hydrolysis and I will heat it. So what will happen after heating? Okay, so your HSO4 is converted into your H2O. Okay, H2O will have what? H plus and OH minus. So this OH minus will go and attack here. So you will get the ethanol as the product. So yes, option number C is the correct answer. Yes, so most of you have answered it as option number C itself. Yes, very good. Okay, so let us go for the next one. So C was the correct answer. Okay. So which one of the following compound has the most acidic nature? So these are the four options. So you have to tell which one of the following has the most acidic nature. So these are derivatives of phenols. Okay. So we are considering the phenols. So last class we have seen about alcohols. Okay, alcohols because of presence of electron donating group. Okay, so we have seen that all things, how the acidic nature. So now we are discussing about phenols. Okay, give your answers. You can use the chat box for answering. Okay, I've got Varun Raj has answered as A. Navyashri has answered as D. Others? What about others? Yes. This is a benzyl alcohol, first one. Second one is a phenol. C is a hexa, okay, cyclo hexanol. Okay, then this is a bicyclic compound. Okay, so this is a bicyclic, not cyclic. Yeah, it is a cyclic compound. So two rings are fused here. Okay, Vedvati has answered as C. Others? Okay, I've got three different answers, A, D, and B. Okay, one more answer. So let's see. Yes, others don't know the answer. Okay, Mehak has also answered as B. Okay, so two answers for B. Okay, fine. So let us see now here. So 54th one. Okay, so here we know that. Okay, so when we are considering about benzyl alcohol, okay, so that is your okay, and here you have a phenol ring, and these are the cyclic bicyclic compounds. Okay, so here when we are considering this four, we know that phenol. Okay, phenol is most acidic. So phenol is most acidic. Why it is most acidic? Because there is a conjugate base. Okay. Now when your phenol, okay, when it reacts with NaOH, when it reacts with NaOH, what you get? You get sodium phenate. Okay, you get sodium phenate. Now this sodium phenate, Okay, it is a that is its conjugate base. So phenol is the that is of sodium phenoxide. So this is sodium phenoxide, and this sodium phenoxide, it is a conjugate base of what? Your phenol. So this is resonance stabilized. Okay, so this is resonance stabilized. So how it is resonance stabilized? See here. So I'll just draw the structures. So here O minus. Okay, so this will undergo the resonance stabilized. So they will give you the structures. So minus O plus. Okay, so again here, so the negative charge has been stabilized. Okay, so negative charge has to be stabilized. So like this, the bond movement takes place. Okay, and you get the negative charge here. So again, this charge is stabilized. Okay, to give you a O minus like this. So like this. Okay. So phenol. So phenol is the most acidic because it's phenoxide. Okay, because it's phenoxide ions. Okay, because it is more stabilized in resonance. Okay, while rest of these three compounds, when we are talking about three compounds, okay, these are alcohols. Okay, so these all three are alcohols. Okay, so this is a primary alcohol, and this is a secondary alcohol, right? So sorry, this is a tertiary alcohol, right? So here they are corresponding bases. Okay, they will not be resonance stabilized. Okay, they do not exhibit any resonance, these three, but your phenol. Okay, phenol, because of its conjugate base, that is your phenoxide ion. Okay, it will be resonance stabilized. Okay, so there is negative charge, it is resonance stabilized. So it is option number B. So option number B, phenol is the most acidic, okay, among the following. Okay. So let us go for the next one. When sodium ethoxide is heated with ethyl iodide, the new compound formed is. Okay, when sodium ethoxide is heated with ethyl iodide, the new compound formed is A. Sodium ethoxyiodide, B. Butyl ethyl ether, C. Diethyl ether, and D. A mixed ether. D. A mixed ether. Yes. So, okay, Naveshri has answered as A, Vedvati has answered as C, Prithviraj has answered as A, Tasmiya C, Sharath has answered as C, Mehek has also answered as C. Okay. Okay, one more answer. Varun Raj has also answered as C. So when sodium ethoxide is heated with ethyl iodide. So let us write sodium ethoxide. Okay, so C2H5 ONA. So O minus Na plus. Okay. So this is sodium ethoxide. Sodium ethoxide is heated with what? Ethyl iodide. So C2H5I. Okay, let me take it this side. So C2H5. Okay, so this is a sodium ethoxide, and this is a ethyl iodide. Okay, this will give you what? This will give you a compound. See here. So NaI plus C2H5O, C2H5O, C2H5. So it is a diethyl ether. It is a diethyl ether. So it is a ROR link, right? ROR link. So it is a ether. So it is diethyl ether. Yes, C. Very good. Okay. So Vamshi Krishna has also answered. Good. So most of you have answered it as A, and A is the, sorry, C, and C is the correct answer. Okay. Good. Very good. So let us go for the next one. So phenols do not react with one of the following. So phenols do not react with what? A, alkali metals, B, sodium hydroxide, C, potassium hydroxide, and D, sodium bicarbonate. Okay, Tasmiya, Vedvati have answered as D. Yes. So option number D is a correct answer. Okay. So when you see the reactions of phenols, okay, it reacts with your alkali metals. Phenols react with alkali metals. They react with sodium hydroxide and it forms sodium phenoxide. Okay, it reacts with potassium hydroxide and it forms the potassium salt of phenol. And but it does not react with sodium. Okay, sodium bicarbonate, that is NaHCO3. NaHCO3. So it does not give any product. Okay, your phenols. So this is option number D. Yes, option number D is the correct answer. So option number D is the correct answer. Very good. Okay, so yes, I've got some more answers. So Mehak have answered, Vamshi Krishna, then Prithviraj, Navyashri, yes. Varun Raj, yes, your answer is correct. So option number D is the correct answer. So let us go for the next one. So this is a reaction. Okay, so you have a tertiary alcohol and you are reacting it with the copper. Okay, so copper is used as a reducing agent and you get a product Z plus water. So what is this Z? So let me write the structure. So then you give me the product. Okay, so you have a tertiary alcohol. Okay, you are reacting with copper. Okay, you reduce it to give you Z plus water. So what is this Z? What is this? Z. Okay, Tasmiya has answered as C. Tasmiya has answered as C. So this is a tertiary butanol, right? Tertiary butanol. So you have 1, 2, 3, and 4 carbon. So tertiary, and this is a tertiary carbon. So 1, 2, and 3 carbons are attached to this carbon. So it is a tertiary butanol. Okay, tertiary butanol. So this, when you treat it with copper, okay, that is what copper is a reducing agent. So what we are going to do? We are going to add hydrogen. Okay, reduction means addition of hydrogen. So what will happen? So CH3, okay, C, and your water. So your, I'll show you. I'll explain it down. So C, okay, CH3, C, then H, your C, H, 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 CH3 and OH. Okay. So what will happen here? So your one of the hydrogen and this water. Okay. So this will be eliminated. Okay, it will be eliminated. So like this. Okay, so this will move as a water molecule. Okay, it will move as a water molecule and you will get what? CH3, C, double bond CH2 and CH3. So option number C. Option number C. Okay, option number C. Yes. Yes, Navyashri, Mehak, Prithviraj, Yashwant have also answered it as option number C. Yes, very good. I hope you are understanding. Yes. Okay, so let us go for the next one. So in the following reaction, okay, this is a reaction where we have a ethanol. Okay, we have a alcohol, that is ethanol, ethyl alcohol. Okay, and we treat it with concentrated sulfuric acid. We treat it with concentrated sulfuric acid at 443 Kelvin. So this is a temperature and we obtain Z. We obtain Z. So what is this Z? So identify the Z. So alcohol when it is treated with concentrated H2SO4. So this is, we know that, okay, we know that concentrated H2SO4, it is a dehydrating agent. Okay, it is a dehydrating agent. Okay, it is a dehydrating agent, means it is helping. So if you treat it with alcohol, okay, so it will remove the OH group as a water. It will remove the OH group as a water molecule. So C2H5, okay, and OH, so I'll show you. I'll just, so CH3, CH2OH. Okay, if you treat it with concentrated H2SO4, so if you treat it with H2SO4, concentrated H2SO4, means your H plus ions. Okay, so your OH will attack this Okay, and you will get CH3, CH2 plus. Okay, this will be removed as water molecule. Now here, this I will explain. So CH3, C, H, H. Okay, and here, so C, H, H plus and C, H, H and H. So what will happen? So okay, so I'll get CH2 double bond CH2. So option number A. Is it clear? Are you able to see? Are you able to see this? Yes, we have to. What we are doing? Uh, we are rearranging the bond. Okay, so that the charge is balanced. Okay, so we are just balancing there. Yes, option number A. Yashwanta and Vedvati have also answered as option number A. So option number A, that is ethene. So when we are using alcohol and we are treating with concentrated H2SO4, and the role of concentrated H2SO4, it is used as dehydrating. Dehydrating means what? Removal of water. Dehydrating means removal of water. So we are removing water, okay, from alcohol. So your OH group, so your what is happening? Your OH group, lone pairs of electrons are present on OH. It will attack the H plus ions from the H2SO4, and it will form, okay, it will leave as water molecules. So their positive charge is created on the carbon. So by rearrangement, okay, this bond will form double bond and it is neutralized. The bonds are it is neutralized. Okay, so this is the answer. Let us go for the next one. When diethyl ether is heated with HI. So when diethyl ether is heated with HI, what is formed? When diethyl ether is heated with water, HI, what is formed? Yes. What is the answer? When diethyl ether is heated with HI, you heat it. Okay, you have to heat it. You can write like this also. What you will get? So just see. Okay, just see. So one is this product. So one will be your C2H5OH. C2H5OH plus C2H5I. Yes. Let me write it properly. C2H5O, C2H5 plus HI. Okay. So what you'll get when you are heating this, you'll get C2H5OH, that is your alcohol, plus C2H5. So this is a ethyl alcohol or ethanol, and this is a ethyl iodide. Okay, so which is the answer? It is option number A. Option number A, yes. Tasmiya, Vedvati, Bhuvan, Navyashri, Madan, Mahek. Yes, okay, option number A is the correct answer. Okay, so let us move for the next question. Glycerol is very highly viscous compared to propanol. Though both are organic alcohols, it is because of glycerol is very highly viscous, okay, as compared to alcohol, and both are organic alcohols. It is because of A, relatively more extensive hydrogen bonding in glycerol than in propanol. B, the absence of hydrogen bonding in propanol. C, the formation of an addition compound in propanol. D, a large value of surface tension of glycerol. Yes, glycerol. Okay, Tasmia has answered as A. Others? So this is the structure of glycerol. Okay, this is the structure of glycerol. I can also write it as CH2OH, CHOH, and CH2OH. So what you can see in this alcohol, you can see that there are OH groups. Okay, so both are organic alcohols, so which is because of, so glycerol. Okay, so it can form hydrogen bonding. Okay, it can form more hydrogen bonding in glycerol than in propanol. Propanol structure is what? CH3, CH2OH. Sorry, CH3, CH2, CH2OH. Okay, 1, 2, 3. So 1, 2, 3 is propanol. Okay, CH2. So 1, 2, and 3. So it is propane all. So when you can see this structure and this structure, there is more hydroxy group. So this can form extensively higher hydrogen bonding. Okay, then your propanol. So because of that, glycerol is highly viscous as compared to propanol. So Mehak Vamshi Krishna has also answered. Varun Raj has also answered as A. Navyashri, Tasmiya, Madan. Yes. Okay. Bhuvan. Okay, so let us go for the next one. The boiling point of glycerol is more than propanol because of. The boiling point of glycerol is more than propanol because of. Okay. So Vedvati has answered as C. Vamshi Krishna has answered as B. Tasmi has answered as C. Varun Raj has also answered as C. Okay, let us see now. So boiling point of glycerol is more as compared to that of propanol. So again, CH2OH, CHOH, and CH2OH. Okay, and CH3. Now here, what you can see, the structures. Yes, because of what? Just now we have seen. So because of hydrogen bonding. So boiling point of glycerol is higher than that of propanol. Okay, why? Your glycerol is having higher this what? Hydrogen bonding because of this presence of three lone pairs of that is three hydroxy group. So because of the three OH groups, because of three OH groups, what happens? Because of three OH groups, the boiling point is higher. Okay. So Mehak and Naveshri has also answered as C. Very good. Okay. So let us go for the next one. So which of the following will not form phenol or phenoxide? Second question. Which of the following will not form phenol or phenoxide? Yes. Okay. Vedvati has answered as C. Mehak and Naveshri has answered as B. Okay. Taspiya, Vamshi Krishna has answered as B. Tasmi has answered as C. Okay. Let us see then. second one. Okay. So what are the structures? Okay, so this is a benzoic, C6H5 and triple bond N. So this is a N2Cl, BDC. Okay, benzene diazonium chloride compound. Then you have SO3Na. Okay, sodium salt of sulfonic acid. Okay, then another you have chlorobenzene. Then you have yeah. So BDC, this is used for preparation of your phenols. Your amines. Okay. So this is used for preparation of amines. Now your sulfonic acid. Okay. So this is also what? So your from this okay NH2. It will form what? It can form phenol or phenoxide. Okay. Further, if you treat okay. So further, it can obtain your phenol or phenoxide. So these three, okay. So these three from this, okay, from these three, you can prepare your phenols, okay, or phenoxide ion can be prepared. But for benzoic acid, from benzoic acid, you cannot obtain, okay, you cannot form phenol or phenoxide. Yes. So option number D. The option number D is the correct one. Okay, let us go for the next one. Ethanol and dimethyl ether form a pair of functional isomers. The boiling point of ethanol is higher than that of dimethyl ether due to the presence of. So you can see that both are having the same molecular formula, right? C2H6O, right? So both are having the same molecular formula. So they are acting as a functional isomer. So why the boiling point of ethanol is higher as compared to ether? Because of the hydrogen bonding. Because of the hydrogen bonding in ethanol. Yes, option number A. Okay. So in diethyl ether, there is no H. Okay, only oxygen atom is there. So it cannot form any hydrogen bond. So okay, so because of the boiling point. Fine. Okay, so option number A, yes. Vedvati, Naveshi, Tasmi, and Mehak has also answered. Okay, so the ionization constant of phenol is higher than that of ethanol because of the ionization constant of phenol is higher than that of ethanol because of A, phenoxide ion is bulkier than ethoxide. B, phenoxide ion is stronger base than ethoxide. C, phenoxide ion is stabilized to delocalization. D, phenoxide ion is less stable than ethoxide. So the ionization of phenol is more as compared to that of ethanol. Okay. Now here, so here, okay, phenol is there. One is your phenol, another is your ethanol. So the ionization constant for phenol is high. Okay, and this is low. What is the reason? In your this, okay. Now phenol, it can, when it loses the proton, it will form a phenoxide ion. So this phenoxide ion, okay, and here when it loses the proton, it will form what? CH3, CH2O. Okay, it will form a alkoxide ion. So alkoxide and phenoxide can be resonance stabilized. Okay, it can be stabilized to delocalization. So phenoxide ion is stabilized to delocalization. Okay. So option number C, alkoxide ion, it is cannot be stabilized. So phenoxide ion can be more stabilized than your alkoxide. So option number C is the correct one. Okay, so who all have answered as C? Yes, Vamshi Krishna, uh, Yashwant, Mehak, Varun Raj, and Vedvati. Yes, very good. So let us go for the next one. On reaction with hot concentrated H2SO4, which one of the following product loses a molecule of water? Yes, just now we have seen the reactions. Yes, when you have a alcohol. Okay, yes, very good. Who has answered? Yashwant has answered. Yes, D is the correct answer. Okay. Yes, Vedvati has also answered. So D. Okay, so whenever you have a alcohol, okay, whenever you have alcohol and when we are using a concentrated H2SO4, as we know, concentrated H2SO4 is what? It is a dehydrating agent. Okay, it is used as a dehydrating agent. So it is used in removal of water. Okay, it is used in removal of water molecules. Fine. So option number D. Okay. Next one. Lucas reagent is very important. One more question. Okay, so this is also asked during theory. What is Lucas reagent? Okay, Vedvati has answered as A. Yashwant has answered as A. Tasmi has answered as A. Yes. Others? Yes. Mehak, Vamshi Krishna, Navyashri. Yes, it is A. Very good. So you all know this. Very good. Okay. So Lucas reagent is nothing but it is concentrated HCl and anhydrous. Okay, anhydrous means what? Anhydrous means no water molecule is associated. Okay, anhydrous. And hydrous means water molecule is associated. Anhydrous means no water molecule. Okay. So what is that? Lucas reagent? Lucas reagent is concentrated HCl and anhydrous ZnCl2. Okay. Option number A is correct answer. Very good. So let us go for the next one. Okay, Varun Raj and Shravat has also answered as A. Okay, so let us go for the next one. So this is the question. So in this reaction, okay, when you heat this compound, okay, so which of the following compounds will be formed? Which of the following compound will be formed? So this is a mixed, okay. So here it is CH3. Okay, this is joined. This is joined. Okay, CH3. It is not separate. So this is a ether. Okay, you have a CH3, CH, CH3, CH2, O, CH2, uh, O, CH2, CH3. You heat it with HI. Okay, you heat it with HI. What you will get? What you will get? What you will get? You will get what? What you will get? CH3, CH, CH3, CH2I plus CH3, CH2OH. Right. So which is the answer? It is option number D. It is option number D. No, we have to see the, just a second, just a second. What we have to see now? Mm, just a second. So I have a ether. Okay. Now here the linkage. So this is a not a symmetrical ether. Okay. On the either side of the O, you have a unsymmetrical ether. The R groups are different. So that time what you have to see, so it is a mixed ether. What it is called as? It is called as mixed ether. Okay. So whenever you have mixed ether with two different alkyl group, what will happen? You know, one will be alcohol product and another will be a alkyl halide. Okay, another will be a alkyl halide. Okay, so so this will depend on what? It will depend on the nature of alkyl group. So whether it is primary or secondary alkyl group is present. So whatever the lower alkyl group is there, right? So this is a lower alkyl group. So this will form what? It will form the alkyl halide. So this will form alkyl halide and this will form the alcohol. This will form the alcohol. Understood? So whenever you have mixed ether, whenever you have mixed ether or unsymmetrical ether, you have to follow this thing. Okay. So you know that products will be alcohol and alkyl halide, but the substitution, so whether it is a primary primary alkyl group or secondary alkyl group, based on that, so whatever the smallest alkyl group is there, that will form alkyl halide, and the next one will form the your alcohol. So the products are, when you heat it, you get CH3, CH, CH3, CH2OH. Okay. Plus CH2, sorry, CH3, CH2I. Okay. So this is the answer. So which is the answer here? Option number C. CH3, CH, CH3, CH2OH. Yes, option number C. So who all have answered as option number C? Let us see. Okay. Prithviraj. Prithviraj has answered as option number C. Okay. Anybody else? No. Only Prithviraj has answered. Okay. So option number C is the correct answer. Is it understood now? Is it clear? Okay. So whenever you have a unsymmetrical ethers, or when you say mixed ethers, okay. So that time what will happen? The lower alkyl group will form the lower alkyl group will form what? Lower alkyl group will form the alkyl halides, and the higher alkyl group will form the alcohol. So whenever you are heating with hydrogen iodide, okay, one alcohol and one alkyl halide is formed. Okay, fine. So let us go for the next one. Which one of the which one is formed when sodium phenoxide is heated with ethyl iodide? So let me write it. So this is your sodium phenoxide. So this sodium phenoxide, when it is heated with ethyl iodide, when it is heated with ethyl iodide, what is formed? Okay. So Varun Raj and Yashwant has answered as A. So when sodium ethoxide, okay, it is reacted with this, what you will get? Sodium phenoxide is heated with ethyl iodide. Okay, so what you'll get? One will be your, okay, Vamshik Krishna is also answered as A. Okay, let us see. Okay, let us see. So when you heat it with this, what you will obtain? So one will be your, so like this, the product will form here. Okay, and this will add with this. So you will get NaX, NaI, NaI plus So you'll get ethyl phenyl ether, ethyl phenyl ether, and sodium iodide, ethyl phenyl ether. So it is option number B. Okay, option number B, not A. Okay, option number B. So you said phenotol. No. Okay, you will get option number B. So sodium phenoxide is this. Okay, sodium phenoxide. When you heat it with ethyl sodium phenoxide. Okay, when you heat it with ethyl iodide. So this O minus, this is minus, this is plus. So O will get attached to the C2H5 and NaI is formed. So ethyl phenyl alcohol. Ethyl phenyl alcohol. Just a second. Okay, the name not ether, so it is called as phenotol. Yes. Okay, okay. So yes, fine. So option number A. Okay, so phenotol, yes, you are right. So option number A. Okay, so option number A is phenetol. So it is named as phenetol. Okay, so C2H5, that is ethyl, that is okay, ethyl group or phenyl group. So it is a phenetol. Okay, option number A is the correct one. Yes, okay, good. Next question. Let's go for the next question. Okay. How many isomers of C5H11OH will be primary alcohols? C5H11OH will be primary alcohols. How many isomers? So one possibility is CH3, CH2, 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 1, 2, 3, 4, 5. Okay, so see 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. Okay, then another possibility is CH3, CH2, CH3, okay, CH2OH. Then another possibility is CH3, CH3, then CH2, CH2OH. Okay, then another possibility is I can create a tertiary alcohol. I can create a tertiary alcohol. So 1, 2, 3, and 4. Okay. So 4. Answer is 4. Yes, Vamshi Krishna, Varun, Yashwant, Sharad, Mehak, and Tasmiya has answered as P. Very good. So last question. HBr reacts fastest with. HBr react fastest with. Varun and Yashwant have answered as B. HBr reacts fastest with. So we know that greater the stability of carbocation, okay, more reactive is the alcohol. So here the 2-methyl propane to all, okay, that is 2-methyl propane to all, okay. So propane it is not propane, okay, propane to all. It is what it will have what tertiary alcohol, okay. So 2-methyl propanol, it is one propanol, it is a primary 2-methyl propanol. So CH3C, so CH3. So CH3, CH2, CH2OH. So add 2-methyl. So 1, 2. So here it is CH3. So this is a secondary alcohol. Okay, so this is a secondary alcohol. Then here it is a propane is primary. This is primary. So this is a tertiary. Okay, so tertiary alcohol, when it is forming a carbocation, this is more stable as compared to primary and secondary. Okay, so primary and secondary, so tertiary carbocations are more reactive. So your HBr will react more readily with the alcohol. Okay, so fine. So I hope Yes, Tasmi and Mehak have also answered. Okay, so I hope all the questions are clear. Yes, is it clear? Fine. So by this we have completed the questions on alcohol, phenols, and ethers. Okay. So tomorrow we are going to continue with the aldehyde, ketones, and carboxylic acid. Okay. So organic chapter, aldehyde, ketones, and carboxylic acid. So after this, okay, the link will be sent. Google Meet, Google links will be sent. Okay. So from that you can take the test. Okay, and see how much you have understood, and if you have some books, or you can solve some previously solved papers, okay, so that you will be more confident enough, okay, so in what you have understood till now, okay, so you can just see what all you have understood. Fine. Okay, so try to solve much questions. Okay. Okay, so fine, so I'll end the session here. Okay, I'll end the session here, so we will meet in tomorrow's class. Okay, so tomorrow I'll be discussing aldehyde, ketones, and carboxylic acid. Okay, so I shall end the session here. Okay, so thank you. Thank you, dear students.